All right, good morning, guys. Today we're going to do 1.5 exploring angle pairs. All right. So last lesson 1.4 was covering measuring angle pairs, but today we're going to dive into different types of angles. Okay. So the first one that I have is adjacent angles. Okay. Now adjacent means touching together, side by side, next to. All right. So two angles that are touching, connected, side by side, etc. Okay. But the definition is adjacent angles are two coplanar angles with a common side, a common vertex, and no common interior points. Okay. So for example, let's just say here we have a straight angle, and then we have a ray. So we have angles 1 and angle 2, okay? These two angles share a common side, a common vertex, but no common interior points. So angles 1 and 2, angles 1 and angles 2 are adjacent angles, all right? Now, another one would be like, let's say we have an angle and say this is angle 3, this is angle 4. Right here, they share a common side right here, a common vertex right here, and no common interior points. So we would say angle 3 and angle 4 are adjacent angles, okay? Now, moving on to the next one, okay? Vertical angles. Vertical angles are two angles whose sides are opposite rays, okay? Two angles whose sides are opposite rays. Vertical angles are congruent, okay? So I'm going to draw our picture like this. Okay. So here we have an opposite ray, and here we have an opposite ray, all right? So let's call this angle 1, 2, 3, 4. Now, the angles that are opposite, so angles 1 and angles 2 are congruent. So angle 1 is congruent to angle 2, and then angle 3 is congruent to angle 4. So angle 3 is congruent to angle 4, okay? Now, they have to have sides that are opposite rays, okay? They have to have sides that are opposite rays. All right, so the third one is complementary angles, okay? And complementary angles are two angles whose measure has a sum of 90, okay? Each angle is called the complement of another, all right? So let's say we have a angle with a ray, okay? And this angle is a right angle, okay? And we'll call it angle 1 and angle 2. Now, if we were to add angle 1 and angle 2 together, well, it'll make up this entire angle right here, okay? So we would say that those two angles are complementary. So angles 1 and angle 2, okay? They would add together to be 90. Now, let's just say we have two separate angles, all right? We'll call this one angle A, and we'll call this one angle B, okay? Now, let's say angle A is 47 degrees, and let's say angle B is 43 degrees, all right? Now, one way to check and see if these two angles are complementary is just add the two degrees together, okay? So 47 plus 43, we get 90, all right? So angles A and angle B are complementary because the sum of the two angles is 90. All right, the next one is supplementary angles, okay? Supplementary is very similar to the complementary angles, but now instead of the two angles who have a sum of 90, will now have a sum of 180, okay? So we know that a straight line or angle has a degree of 180, okay? And now I'm going to draw a ray, and we'll call this angles 3 and 4, all right? Now, if we were to add angles 3 and angle 4 together, we would get 180, okay? That's what we've been doing in 1.4 with the angle addition postulate, all right? So two angles added together that give me 180. Now let's look at an example. Let's say I have two separate angles. I have angle A, which is 43 degrees, and then I have angle B, which is 137 degrees. Now, 43 plus 137, this is angle B, sorry. 43 plus 137 is 180, all right? So angles A and angles B are supplementary, okay? Very similar to complementary. Complementary is 90, supplementary is 180. All right, so now we have a linear pair, okay? And a linear pair is a pair of adjacent angles whose non-common sides are opposite rays. So what that means is we will have a straight line with a ray, okay? And we'll call it B, and then we have 2 points. Points A and C. Now, a linear pair is a pair of adjacent angles whose non-common sides are opposite rays. So the opposite rays are ray BA and ray BC, okay? And the angles of a linear pair form a straight line, okay? Obviously, we could tell that line AC is a straight line, so it is 180 degrees, all right? Now, the next part is very, very important, okay? Because this term is seen a lot in geometry, to be honest with you guys, and it is an angle bisector, okay? Now, when you hear the word bisector, you think of, bisect, okay? Dividing something, okay? Cutting into something. Well, that is true here, okay? So an angle bisector is a ray that divides an angle into two congruent angles, okay? So let's just say I have angle XAZ, all right? XAZ. Point here. And let's just say we have ray AY that is our angle bisector. Okay, it bisects angle XAZ. Now, since it bisects angle XAZ, we now have two congruent angles, okay? So the bisector makes XAY and YAZ congruent, all right? So a angle bisector is a ray that divides an angle, one whole angle, into two congruent angles, okay? Kind of like the midpoint that we looked at in 1.3, okay? But now we're dealing with an angle bisector, so it bisects one angle into two congruent angles, all right? And we would say that the measurement of angle XAY is congruent to the measurement of angle YAZ. All right, so now we have part 1, identifying angle pairs, okay? So it tells us to use the diagram at the right. Is the statement true? Explain, okay? So the first thing that we want to look at is A, okay? And it says that BFD, so BFD and CFD, let me change my color so we can see, and CFD are adjacent angles. Now, do not get confused. Those angles are, they look like they're right beside each other, okay? But they have a common side, which is FC. So this is the common side right here. But they have interior common points, okay? Because it looks like CFD lies within BFD. Well, that is true, okay? This would be the common interior points. So no, they are not, okay? They are not adjacent angles, Okay, let me erase this so we can move on to the next example. All right, part B asks if AFB, okay, AFB and EFD are vertical angles. All right, now vertical angles are two angles whose sides are opposite rays. Now we have to be really, really careful here because FA and FD are opposite rays, but BE or BF and FE are not. So no, because BF, or excuse me, should be FB. FB and FE are not opposite rays. All right. And C, it asks if AFE and BFC are complementary. All right. Now we're able to decide this here because we have a degree for AFE and for BFC. The degree for AFE is 62, and the angle for BFC, or the degree for BFC, is 28. Now 62 plus 28 is 90. So yes, they are complementary. All right. In part 2, it says, what can you conclude from the information in the diagram? All right. Well, the first thing is I know that angle 1 and angle 2 are congruent because of the arcs. Angles 3 and angles 5 are vertical angles because their sides are opposite rays, okay? And then angles, we'll just call them out, angles 1 and 2, 2 and 3, 3 and 4, 4 and 5, and 5 and 1 are adjacent angles because they are right next to each other, all right? They're side by side, and we know that adjacent angles are two angles with a common side, a common vertex, and no common interior points, okay? They don't overlap here, so that's why we have so many adjacent angles. Now, the third thing is angles 3 and 4 and angles 4 and 5 are supplementary, okay? So angles 3 and angles 4 make up a straight line, so their degree is 180, and then angles 4 and angles 5 is also a straight line, so we could say that they are supplementary, all right, supplementary. All right, part 3, we're finding the missing angle measures, all right? So we're given a diagram over here to the right, excuse me, can't talk today. And it says that angle KPL and angle JPL are a linear pair, okay? Linear pair. Now, we know that a linear pair forms a straight line, okay? So KPJ is a straight line. Now, if KPL is 2x plus 24 and JPL is 4x plus 36, what are the measures of angles KPL and JPL, all right? So the first thing that I'm going to do is that we're going to have to set up an equation, all right? And we're going to have to do a little bit of adding and to the equations that are given to us, and we are going to have to set them equal to 180, all right? Because we know that KPJ is 180, and this angle, and this angle make up to be 180. So we have 2x plus 24 plus 4x plus 36 equal to 180, all right? So 2x plus 4x is 6x. 24 plus 36 is 60. Okay. We set it equal to 180. Now to subtract 60 from both sides. All right, so 60 minus 60 becomes 0. And then we have 6x is equal to 120. Now, 6 is being multiplied by that x in mathematics. To undo multiplication, we use division. So divide both sides by 6, and x is equal to 20. Okay, x is equal to 20. Now let's see if it works out. So we could always check our work. So KPL was 2x plus 24. All right, 2 times 20 is 40, plus 24 is 64. Which looks like it's true because we know we could look and tell that KPL is an acute angle and 64 is less than 90, right? And then we have JPL, which is 4x plus 36. So we have 4 times 20, which is 80, plus 36, which is 116, and 64 plus 116 gives us 180. All right, so now I know that I have done my math correctly. All right, last part, we're using an angle bisector to find angle measures, okay? So here it says ray AC divides DAB, all right? So I'm gonna draw a picture. And let's say here we have DAB, all right? And ray AC bisects the angle, all right? And if DAC, so this mark is 58, then what is this angle right here, okay? Well, we could go back and look at the definition of an angle bisector, okay? And an angle bisector is a ray that divides one angle into two congruent angles, all right? So what that means is if DAC is 58, then CA or DAB, okay, will be DAC plus CAB. So CAB will also be 58, all right? Now, if we wanted to determine the angle measure of DAB, well, it's just 58 plus 58, which is what? 116. So the measurement of angle DAB is 116.